Hey everyone, Mr. Herc here. Today I'm going to be going over the AP Precalculus Exam 2024 free response questions. So AP Precalc or any AP class will release the FRQs for the last 3 or so years. And so this was the FRQs 2 years ago. You may have seen very similar problems to these, and so try these on your own. This is going to be another good source of exam practice for your AP semester summative as well as your AP exam, just to get you more prepared to the types of questions that you could see and what I'm looking for as I grade them. So I'm going to go through each one question by question, explain the correct answer, like work it out, and then show you exactly what I'm looking for when I'm grading each question. Right, so number one, the figure shows the graph of function f on its domain. Here we are given three specific points. So -3, 1, 0, 1, and 3, 1 are given to be on the graph of f. Here, that way we don't have to guess, is it, exactly on the point or not? They will give us three specific points here, and you'll see why it's important later. The function g is given by g of x equals 2.916 times 0.7 to the power of x. Here the function h is defined by h of x is g of f of x. Find h of 3 as a decimal approximation, or indicate that it's not defined. So this is a composite function. So this is going to be g of f of 3. We now want to look and find what is f of 3 even from the graph. So one thing is really pay attention on f versus g. Which one does the question ask about? What function am I looking at? Because you don't want to confuse these two functions. They are clearly labeled. G will always be the equation. F will be the graph or the table, depending on the question or year. And so just pay close attention to that. Here, f of 3 is going to be what is your output when x is 3? That's going to be 1. We also know that from this point here, 3, 1. So this is 1. And so I'm going to replace that whole inside with just the number 1. Then what I'm going to do is I'm going to type in Desmos, g of x equals, and that full equation. Notice how I have parentheses around the 0.7. I have the g of x equals. I have everything basically copy and pasted from the AP exam. And then I'm evaluating g of 1. So that's what I'm going to type in. It will spit out that decimal. And I'm going to want to give it to at least 3 decimal places. So 2.041 should be our answer for part 1. The two things I'm looking for here is I'm looking for this to at least 3 decimal places. If you put that 2 at the end, totally fine. I'm also looking to see this number 1 somewhere in your work to show that you found that intermediate number, that middleman, if you will, for this question. So those are the two things I'm looking for. Question number 2, find all values of x for which f of x equals 1, or indicate that there are no such values. Here I see f of x equals 1 right there, and then the three values are going to be there, there, and there, which will correspond when x is 3, x is -3, and x is 0. So -3, 0, and 3 should be my three answers there. We also are given those 3 points, and that is where f of x, right, your y value, is essentially equal to 1. So the second question will always ask for which x values equal a certain y value. So just be prepared for that. I do need all 3 values. You only get partial credit if you give 1 or 2 correct ones there. All right, part BI. Find all values of x as decimal approximations for which g of x equals 2, or indicate that there are no such values. Notice g of x, like I said, equals 2 is different from g of 2. This is not what we're looking for with this question. This is what we're looking for. So what I would do is I would literally type in both equations, 1 and 2, into Desmos for Betum. And then you're finding the intersection point. So just hover over that point and you should get x to be, we don't care that y is 2. and then 1.057. That should be our answer there. I've had students that put 1.057 comma 2. I guess that's okay, but here it's really only asking for x values, so that's really what I'm looking for. There is just the x value. There's only one right here, but if there was multiple, make sure to give all of them. Otherwise, you will get points deducted. All right, number BII. Determine the end behavior of g, so this function, not this graph, as x increases without bounds. That's as x approaches positive infinity. Express your answer using the mathematical notation of a limit. So taking a look at this graph, if you know the exponential rules, we know in the form a times b to the power of x, as long as a is positive, and then here b is less than 1, this is going to be exponential decay, which should look like this, with this side approaching 0 as you go to the right forever. So how would we write this end behavior? We would write the limit as x approaches positive infinity, give the correct function, which is g of x, and this will approach the value of 0. So that should be our answer there. You can also look at Desmos and just look at the general trend, right? If you hover over any of those points, it will say that x coordinate comma 0. If you were to include the other limit statement, you would need limit as x approaches negative infinity of g of x equals positive infinity. Both limit statements need to be right, otherwise the whole question is wrong. So I would say stay away from writing that extra limit statement. I would not write it, and I would only write the one they ask for there. All right, part C, determine if f has an inverse function. Give a reason for your answer based on the definition and the graph. So here the answer is no, right? It clearly does not pass the horizontal line test. And more specifically, if we were to graph the inverse, the inverse would not be a function. Graphically, it would look a little something like this, which would then not pass the vertical line test. We don't need to explain any of that. Here for part 1, we can just write no. It does not have an inverse function. And then give a reason for your answer based on the definition of a function and the graph of y equals f of x. This means that it wants specific points. So I would say the perfect answer here is f is not 1 to 1, so that talks about the definition. And then as I want 2 points that break the horizontal line test, I don't want to mention the horizontal line test. So and then I would say, let's go with the integer coordinates, right? -3 comma 1 and 0 comma 1 have the same y value. That would be perfect there. So there, we not only talk about the definition in both of those, but we also point drop, not name drop, but point drop 2 specific points that break it, right? -3 comma 1, 0 comma 1. You could also mention 3 comma 1. You only need to mention 2 points that break it, right? You don't have to mention all 3. I would say use those 3 points that they give you to your advantage, because it's a lot better than having to try to guesstimate some of these decimal places here or here or here, right? So stay away from messy decimals and use integer coordinates that they clearly give you to your advantage to answer this question here. All right, number 2. On the initial day of sales, t equals 0 for a new video game, there's 40,000 units. 91 days later, there's 76,000 units. This was in the form a plus b ln t plus 1, where g of t is the number of units sold in thousands on day t since the initial day in sales. So use the given data to write 2 equations that can be used to find a and b. The first thing I want to do is find 2 points. So my 2 points that I'm going to pull are going to be 0, comma, and a lot of students want to write 40,000, but remember your y variable is in terms of thousands, so I'm just going to put 040. Then you have 91 and then 76 should be your 2 points there. Plugging them into this function, g of t is equal to a plus b ln t plus 1. Here, this is going to act very similar to y equals a plus b ln x plus 1. And now we have our xy coordinate that we can just plug in. So this should be 40 equals a plus b ln 0 plus 1. And we don't even need to simplify the 0 plus 1. The next one is 76 equals a plus b ln 91 plus 1. And that should be our answer for number 2 there. All right, number 2, AII. Find the values of a and b as a decimal approximation. So here, when we plug in the points in Desmos, we come across an error. And so why is this the case? Well, if we plug in here, if we take a look, the logarithmic regression is in the form of a plus b ln x, or y equals a plus b ln x. If you try to plug in 0, 40 into that, right, you would be plugging in a and then a plus b ln 0. That's not what we want. You can't take the natural log of 0 or a negative number. So, but the equation that we had was t plus 1. So how can we adjust for that? And it's pretty easy. What we're actually going to do is we're going to take those two coordinates, 0, 40, and then 91, 76. And because you see a t plus 1 there, we're going to add 1 to our x coordinates to get 1, 40 and 92, 76 there. Once we have our 2 points plugged into a table, which then you're going to click this little icon right there in the top left corner, that will add a regression line, and then we're going to do a logarithmic regression here. Once we get this, we get our equation of y equals 40 plus 7.96145 ln x. This is going to be our a and our b value here. So this is a, this is b, ln, and then it basically was t plus 1 there, but we basically added that before we plugged it into Desmos. So here, a is just 40. You do not have to add decimal places there. And then b is going to be 7.96 and then 1 should be your answer there. No rounding needed. And so that should be our answer. So just make sure you choose the correct regression line, right? If you have a times b to the power of x, that's exponential regression. You have a plus b ln x. This is logarithmic regression. And then if you have a x squared plus bx plus c, that's going to be a quadratic regression as well. All right, part BI. Use the given data to find the average rate of change, or slope, for the number of units of the video games sold in thousands per day from 0 to 91. Use a decimal approximation, show the work that leads to your answer. So here we want to take our 2 coordinates. You do not have to do the 2 points you plugged in Desmos, but if you did, you will get the same answer, so it really doesn't even matter. I'm going to use the 2 points that we were given right away, so 0, 40, 91, 76, and then plug them into the slope formula, so y2 minus y1 over x2 minus x1. Here we get 76 minus 40 over 91 minus 0. This should then simplify into 36 over 91. That's still no good. You're going to want a decimal. So 0.39 and then 5. You can round it up to 0.396 as your answer to B. What I'm looking for here is either one of those 2 fractions for your work. So that's going to be your work there. And then I'm looking for your actual answer, 0.396 or 0.395, depending on which way you like to round. Part 2, use the average rate of change found in part 1, so use that slope, to estimate the number of units on day 50, show the work that leads to your answer. So here, we're going to use point slope form. So y2 minus y1 equals m times x2 minus x1 here. Once we have this, we know our m is 36 over 91. So let me write that down. The reason why I say that instead of 0.396 is because I don't want to round until the very end when I have to. So I'm going to use the closest thing, which is that exact fraction there in my work. Then I know my x1 comma y1 is going to be one of the 2 points that I already used in the slope formula. Here I'm just going to use 0 comma 40 just to make it easy. So 0 comma 40. And then for my x2 comma y2, here this should be, my x2 is going to be 50. And then my y2, I don't know. That's what I'm solving for, right? You're solving for the y value, the number of units of video games sold in thousands, when your x value, t, is 50. Plugging this all into the equation, I should get y2 minus 40 equals, and then m, which is 36 over 91, times 50 minus 0. I'm going to add 40 to both sides to get y2 equals 40 plus 36 over 91 times 50 minus 0, or 50. This is what I plugged into Desmos now to find my answer, to get y2 equals 59.780. It's okay if you say y2 is around, if you round that to 60,000 video games sold. It's okay if you have this rounded answer, that's okay, but somewhere in your work, I need to see that decimal. So I need to see that decimal. I need to see this equation you use. If you use a different one, that's fine. If you use Desmos, you still need to show your work. You can't just write, I use Desmos if you know how to solve this using Desmos. You actually need to do it by hand. So that's very important. I know some of you guys know how to do it. Just use that as a way to check your work rather than doing your work. All right. B3 here. Let A of t represent the estimate of the number of units of video games sold in thousands using the average rates of change found in I. So this was basically finding the slope between those 2 points and using that to predict at 50. For A of 50, found in part 2, which is right here, A of 50, it can be shown that A of 50 is less than G of 50, which is right there, because this is the graph of G, this is the graph of A of t. Explain why in general A of t is less than G of t between 0 and 91 here. So here we are only looking between 0 and 91. And then y is that straight line below the logarithmic line here. So this is just a graph to show you. You can look at this on Desmos, and as long as you can just sketch out the general shapes of this, you should be able to see, right, in between 2 points, the straight line will be below, graphically, the logarithmic line. So how I would answer this question is copy and paste. What am I explaining, right? That's what the question's asking. So here I would say A of t is less than G of t, where t is between 0 and 91. And then I'm going to say this is because, because G of t is, and the first thing I want to do is talk about the concavity of that regression function. So G of t is concave, and then here it's hard to see, but it's a downwards U shape, so concave down. And then the next thing I want to do is address or talk about the secant line and what 2 points formed it. So, and the secant line from t equals 0 to t equals 91 is below g of t, which is true. This is a perfect answer there. So here's the three things I'm looking for. G of t is concave down. I need to see that somewhere. You could say the rate of change is decreasing. That's fine too. The next thing is the term secant line. And then the third thing is the two endpoints of the secant line, right? It went from 0 to 91. I need to see those 2 points that provided that placement of the line before you finish writing your answer to this question. So make sure that you include the endpoints there. All right, number 3, the maker of the video games reported that daily sales of the video games actually decreased each day after t equals 91. Explain why the error in the model of G increases after t equals 91. So here, this is G, right? This was our model. Why does the error increase when G of t is increasing, but this is the video game sales is actually decreasing? What is the error in the model? Well, the error is how far off were we from our prediction. And so obviously, if we're predicting that it's going up, but what actually is happening is the number of video game sales is actually going down, then obviously those are going in two different directions, and the gap, or how far off we were, or how wrong were we, is getting bigger and bigger and bigger, and we're making more of an error each and every day. So we want to explain this. So I would say the error in G increases after t equals 91 because, so that's just using a complete sentence, and then because G of t is increasing while the daily sales is decreasing. So the gap between them is getting bigger. And that should be my answer for number 2 there. All right, so FRQ 3 will be a sinusoidal story problem. Here we want to find 5 coordinates and then find the values for a, b, c, and d in a sine or cosine equation and answer a few questions about them. So let's break the story problem down piece by piece. The tire of a car has a radius of 9 inches. So here I'm going to label a radius of 9. And the person rolls the tire forward at a constant rate on level ground, as shown in the figure. Point W on the edge of the tire touches the ground, so I'm going to label that, at time t equals 1/2 of a second. The tire completes a full rotation, and the next time it touches the ground is at 5/2 of a second. The maximum height above ground of point W is 18 inches. That makes sense, right? Because if you have the ground and you have a radius of 9, then the maximum height is going to be that diameter, which is 18. As the tire rolls, the height of W above the ground periodically increases and decreases. So taking a look, this sinusoidal function will model the height of W above the ground in inches as a function of time in seconds. We want to find 5 coordinates, so the first thing I want to do is label my y values first. So I know the maximum in this problem is going to be when it's at the very top. That's going to be when it's 18 inches above the ground. At the very bottom, we're kind of given that it should be 0 because it is touching the ground, right? There's no distance between point W and the ground. And then in the middle should be kind of at that center, which is going to be 9, halfway in between 0 and 18. Finding our 5 coordinates, I'm going to label my x or my y coordinates now, leaving a blank space for my x coordinates. 9 and then comma 0. There we go. Now we want to find our x coordinates. So what I'm going to do is, knowing that it touches the ground at time t equals 1/2, and the next time it touches the ground is at t equals 5/2 here, I want to figure out what is my period going to be. And remember, the period, if we take a look from let's say it was 5 and 7, our period is going to be 2 because we do the bigger number minus a smaller number. Now that's with a really easy numerical example, but it works the same with fractions, right? We would do the bigger number, 5 over 2, minus a smaller number, 1/2, to get 4 over 2 as our period, which is just 2. So 2 seconds should be our period. Knowing that, I'm going to extend my graph, and you could or couldn't, so there's lots of different answers you could have. I'm going to extend my graph here and then start this and add in those 2 points and start this at time equals 1/2 or t equals 1/2 here. The reason I'm doing that is because I know that's when it touches the ground, and then this should be 5/2 here. Knowing our period is 2, if we divide that by 4, right, that's going to be 1/2. So the fraction is nice enough where, and they did this very deliberately, the people that wrote this question, where we can literally count from 1/2 to 5/2 here by doing 2 over 2, 3 over 2, 4 over 2, 5 over 2. This should be 6 over 2, and then 7 over 2 here. And those are going to be our coordinates. One other pair of coordinates that you could have is if you wanted to, for F, G, J, K, and P, so let me label those. If I wanted to, I could actually start J at 1/2 comma 0. This then would be 0 comma 9. This would then be negative 1/2 comma 18. This would be 2 over 2 comma 9, and then P would be 3 over 2 comma 18. Here you would have a negative x coordinate, but those 5 points would also be accepted in your answer. So there's multiple different answers that you could have, but those are going to be the 2 most common ones that we'll see here. All right, so knowing that these are our points, this is what we should label, but like I said, you could start J at 1/2 comma 0, and then do K at 2 over 2 comma 9, 3 over 2 comma 18, and then G would be 0 comma 9, and then negative 1/2 comma 18. So we're going to use these coordinates as we work through the future questions, but your answer should pretty much be the same. All right, so part B. Using the points that we know, the function h can be written as h of t equals a sine b, parentheses t plus c, plus d. Find the values of a, b, c, and d. So first off, I ask myself, is it sine or cosine? In this case, it's sine. So that will impact our c value. Everything else will be the same regardless of sine or cosine. A is our amplitude. Our amplitude is the distance, so distance is positive, from max to midline. That's 9, so 9 should be our A value. D is our midline. This is conveniently enough also 9, so even if you get A and D confused for this one, it would be correct. Most of the time, won't be. Once we have that, B is our B value. So remember, we found out our period was 5 over 2 minus 1 over 2, which was just 2. So knowing that our period was 2, our B value should be 2 pi over your period, which is just pi. So B should be pi in this case. And then C is going to be our C value, or this is our starting point. And so remember, for sine, our starting point is going to be negative, or the opposite of our midline going up point, or K. So I would accept either negative 2 over 2 or negative 6 over 2 as a correct answer there. Right, so either of those would be accepted. If it was hypothetically cosine, then C would be negative 3 over 2 or negative 7 over 2 as your two solutions, where it is the maximum point but negative. So that would be in the case that it is a cosine equation. Obviously, this one's sine, so we're going to use those values in our actual answer here. All right, so part C is going to ask about one segment of this graph. So here we are looking from K to P. So I always like to highlight the portion of the graph that we're looking at, which is that blue segment right there. And then which of the following is true about H, which is from K to P? Here, H is going to be either positive or negative and increasing or decreasing. So taking a look from K to P, I like to look at our y coordinates. So here we're looking at our y coordinates of 18 and 9. So this function, or this part of the function, should be solely positive. So we can eliminate C and D because we know it's not negative. And then this function is going up as you go from left to right, so it should be increasing. So A should be the correct answer for CI. For CII, describe how the rate of change is changing. Here you want to see if it's concave up or down. This one is concave down, so I'm going to write concave down. And then I'm going to write the rate of change is, because it's down, it should be decreasing. And that will always be the case. Those two answers will always go together. I would need both parts of this. If you only include one of those two parts, the question will be marked wrong. So really make sure you include both parts there. All right, number 4. This is the one that typically gives students the most trouble. So this is one that I would spend a lot of time on, especially with the notes and homework. So for part A, we want to solve these two equations. So remember, to solve any equation, we're going to set them equal to each other. So we have e to the power of x plus 3. And we want to see, where does this equal 10? To do this first, I have an exponential function in the form of a to the power of b equals c. I want to get x isolated on one side of the equation. So I'm going to rewrite this as log base ac equals b, where that x in the exponent b is now moved to the right-hand side of the equation. This then should be log base e of 10 equals x plus 3. And I'm going to even rewrite the log base e as ln 10 equals x plus 3. And then our final step is going to be subtract 3. So I'm going to write ln 10 minus 3 equals x. And that should be our answer. You could also word your answer as negative 3 plus ln 10 equals x, but it is important that you separate the 10 and the 3. If you just wrote ln 10 minus 3 equals x, this would actually on an AP exam be marked wrong, because this is inferring that you mean ln 7, which is not what we want here. That minus 3 is separate from the 10. So really making sure you are clear with your answer is really important, especially with FRQ 4. For the next one here, we have arc sine of x over 2 equals pi over 4. The strategy here is, how do we get rid of arc sine in one part of the equation? And that's pretty simple. That's going to be taking sine of both sides, because arc sine is inverse trig. So what we do to one side, we have to do to the other. This will cancel out the arc sine, and on the left side, we're left with x over 2. And then here, we're left with sine pi over 4. This on the right side is just a unit circle value. So pi over, or sine of pi over 4 on the unit circle should be positive root 2 over 2. Solving this, I'm going to cross multiply, so we get 2 times x equals 2 times root 2. And then we can divide both sides by 2 to get x equals root 2 as our solution for for question 4AII there. All right, part B. Rewrite j of x as a single log base 10 without any negative exponents in any part of the expression. Your result should be log base 10 and then just one giant expression. So here, the first thing I'm going to do is take any coefficient out front and move it to the exponent. So I'm going to rewrite this as log base 10. Here we have 8x to the 5th plus log base 10, 2x squared, and then minus log base 10, and that 9 gets put into the exponent, x to the 9th there. Once we have this, we're going to throw this all into one giant fraction, where anything with a plus, and the first term is an implied plus, will go in the numerator. So here we have 8x to the fifth times 2x squared. And then anything with the minus will be moved to the denominator. So this is going to be x to the ninth there. This then should simplify into log base 10. And here, if we just left this as our answer, this would be marked as wrong because we can simplify this. So AP would expect us to simplify this to 16, 8 times 2, x to the 7th over x to the ninth, and we're not done there. This can be simplified to log base 10, 16 over x squared, and this should be our answer. So making sure that you know the simplifications AP would expect is really important for this one here. All right, for part 2, rewrite k of x, this trig function, as a single term involving tangent. So taking a look here, we have 1 minus sine squared x. I'm going to start by splitting everything up into its own fraction. So 1 over sine of x times secant x over 1 here. Once we get everything into its own fraction, we want to get everything into a single trig function, which means we got to simplify this 1 minus sine squared. If we remember the Pythagorean identities, sine squared x plus cosine squared x is equal to 1. So if we want to try to get what can we substitute 1 minus sine squared x, I'm going to subtract sine squared x from both sides. This then should be cosine squared x equals 1 minus sine squared x. And I'm going to replace this left side with a single trig function to make it a little easier. So this is going to be replaced with cosine squared x over 1 times 1 over sine x times secant x over 1. All right, once we have that, then we want to get everything in terms of sine and cosine. Those are going to be our two universal trig functions, and having everything in terms of sine or cosine will allow us to cancel anything that we can. So here, cosine squared, I'm just going to leave as cosine squared because it's already in terms of sine or cosine. We have a sine of x in the denominator, and then we have secant x in the numerator, and so that is going to be moved to a times cosine in the denominator. So that should be times cosine x. Here we can cancel out a cosine x with one of the cosine squared x's up top, and we are left with cosine x, one of those, over sine of x there. Taking a look, we know this is cotangent x, but we want this in terms of tangent, so that is just 1 over tan x as our answer there. All right, so for part C here, we're given function m, and we want to find all values in the domain where this is equal to 0. The first thing we want to do is set up our equation. So I would just set both sides of this equation equal to each other. There. And then notice how we're finding all values in the domain. So I'm going to keep that in the back of my head where there is a possibility, not for sure, that we're going to be adding plus 2 pi k or plus pi k. You will only add those in part C only. You will never have to add those in part A or B for FRQ number 4. Once we have this, we want to start by chipping away at the left-hand side to really try to isolate x. So the first thing I see is that inverse cosine. How am I going to get rid of that? I'm going to take cosine of both sides of the equation. So on the right-hand side, we can eliminate or cancel out the cosine, and we are left with tangent of 2x equals cosine of 0. Now, a lot of people will say cosine of 0 is pi over 2, which is very, very, very wrong. Here, remember on the unit circle, cosine of 0 radians is not the same as cosine x equals 0. This would be pi over 2, but this is not what we were asking. We were asking what is cosine of 0 radians? That's going to be right here, which this coordinate is 1, 0. And so if it's cosine, sine, cosine of 0 radians should be 1. So I'm going to replace this with the unit circle value of 1. So here we have tangent of 2x equals 1 there. All right. The next thing that we want to do is we want to solve this general equation. So if we were solving tangent of 2x equals 1, I want to ask myself, well, tangent of what angles, right? Think of this as like a blob. Where would that tangent of that blob equals 1? Where is tangent of what angles equal to 1? And so if it was tangent x equals to 1, I know that's going to be x is pi over 4 and 3 pi over 4. But here it's just 2x, so it's going to be that same thing should be equal to pi over 4 and 3 pi over 4. So here I'm going to set 2x equal to pi over 4 and 3 pi over 4. And here, one thing that's nice about tangent is even though we have both unit circle values, you actually only need one, but instead of adding plus 2 pi k, we're going to add plus pi k, so we can actually get rid of this second equation here, because pi over 4 plus pi, when k is 1, actually accounts for 3 pi over 4 as a general solution as well. Right? Once we have this equation, so remember, for sine or cosine, you're going to need all unit circle values. For general solutions, plus 2 pi k. For tangent, you're just going to need one unit circle value plus pi k. So that is an important difference between a sine and cosine general equation or a tangent general equation like the one we have there. All right, now solving this equation, we are not done yet. So we have 2x equals pi over 4 plus pi k, and then we need to divide both sides by 2 to isolate that x. So I'm going to think of this as multiplying both sides by 1/2, and remember to distribute. So here we should get x equals, and then this should be pi over 8 plus pi over 2k, and this should be our general solution there. This is our answer to part C. Right? If you guys have any questions, please come see me during office hours, and I will see you guys later. Thanks.